All right. Hello, everybody, and welcome. I hope everybody is doing well tonight. Tonight, we are going to be covering handles a little bit more. We already kind of covered them on the last stream, but we are going to be covering them again tonight in a little bit more of an expanded manner. One second. Okay, so basically, where we kind of left off last time was we were kind of toying around with how we were going to implement handles, and we started to refactor our transform system, calling it Xforms and stuff like that. And so we're going to kind of pick up that, and then I'm going to talk about a few things that I did offline. And then we can finally get back to, I think, implementing this stuff in our actual scene and getting our hierarchy going. So, with that all said, I do want to take just a quick second and thank the supporters of the channel who are listed here on the screen, starting with the partners at the top. They are the top tier of subscription over on YouTube memberships and Patreon. They are Gabi Bashir and Gerboles Inc. I would also like to thank all the other supporters listed here on the screen. They are a combination of YouTube memberships, Patreon, and Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated. Of course, I hope it goes without saying that I appreciate each and every one of you viewers, whether you're on the Twitch side or the YouTube side. We do simulcast to both, so if you're not aware of that, we are on both places at once. And I do watch both chats. That being said, this is an interactive stream, so if you guys have any questions or things you want to discuss, feel free to jump in and we will talk about those things. Okay, so let's quickly talk about kind of what I came up with in terms of the direction that we're going to go. So we did get our handles. We got a handle on our handles last time, basically, right? We got that implemented, and that was good to go. We started kind of creating a new Xform structure, but I actually changed up the way that worked after I did some thinking about it. So we're going to talk about that really quickly. And then we also created a hierarchy graph, which is separate from transforms or Xforms. So let's talk a little bit about kind of what the difference is between those things. So I think to do this, I'm going to get out the old trusty paint here. So let's go ahead and fill that, right? And we'll go ahead and switch to, we'll use white for right now. So the way a lot of existing implementations do this, and the one I'm thinking of off the top of my head is Unity, is you have a scene hierarchy, which generally involves some object in the scene, like a game object, right, is what they call it. And then to that, you can have something else attached to it, right? And that just sort of becomes a child of that, and you can have multiples attached to that, right? So you can have multiple children, and then each one of these children can also have children, right? And so the idea is that if you move this guy, then this one and these two really should all move with it, right? Likewise, if you were to just move, let's say this object, right? It doesn't have anything underneath of it, so it would just move by itself. If you were to move this object, then you would also move this object, right? So that's your basic hierarchy. The problem with this is that in this sort of scene hierarchy, there's no way to sort of organize things. So let's say that you wanted to put, I don't know, all your trees under this guy, right? So everything under this, you wanted trees, right? And then let's say, for example, maybe you wanted, I don't know, rocks under this one, under this next one, right? So we'll just say this one is maybe rocks, right? And then as an example, you know, this will be rock 0, rock 1, etc., right? Or whatever they're named, right? So the thing about this is when you're organizing things this way, sometimes all you want as a user is you want basically this to act as a folder, right? And the problem with this setup and the way that Unity does it is each one of these has their own transform, regardless of whether it actually contains any components or things that are renderable or things that actually need to have a transform, right? And the issue with this is partially because of the way it's structured, right? Because Unity actually kind of stacks its objects by the transform, right? That's what establishes the parent-child relationship, okay? And every game object has to have a transform. And so basically the underlying issue here is that there is tight coupling between the two, when really what we should have is a sort of more loosely coupled layout in terms of memory and logic, right? Because we should be able to say, okay, well, we want this one to have a transform, we want this one to have a transform, but this root node here and this sort of folder here doesn't need to have a transform, right? You can't do that in a scenario like Unity. And so we are going to attempt to resolve this issue with our systems. So what we're going to do is we're basically going to split this up into two parts. Dino, good to see you. Thank you for the raid of 12. Welcome. How are you doing tonight? What were you up to? Welcome, raiders. So we were actually just getting started. I feel like the music's a little bit loud. Let me turn that down a little bit. So we were actually just getting started with our stream here, and we were kind of talking about the way that I'm going to be handling transforms going forward, because we're going to kind of refactor that a little bit. But Dino, I hope your stream went well. I know we were talking the other day about OOP. But yeah, basically, I'll take a break from this explanation real quick. I'll circle back to that and give the raiders a quick little explanation as to what we're talking about on the stream. So let me just grab a new tab here. Give me one moment. So we are developing a game engine from scratch, written in C using Vulkan as our initial rendering backend. The game engine is called Kohi, right? So it's kind of a play on the Japanese word for coffee, right? New Jank raiding with a party of 4. Thank you for the raid. I appreciate that. What were you up to on the stream tonight? Good to see you. So yeah, actually, it's so funny. Like a minute ago, I actually just got raided by by Dino. So I'm actually gonna restart my explanation here since we were already kind of in the middle of it. Yeah, Dino's in here. Yep. So what we are doing here is we are developing a game engine from scratch. The game engine is called Kohi. Thank you guys for the follows, by the way. And it is written in C. Using Vulkan as our initial rendering backend. So this has been a project that's been underway now for a few years. And we are kind of doing this as an educational exercise in terms of how to develop an engine, a way to develop an engine. And we're sort of trying and experimenting with different things along the way. So far what we have is it's cross-platform. So it runs on Windows, Linux, and Mac OS. It is 100% free and open source. So we host everything here on GitHub. It is Apache 2.0 licensed, which essentially means if you use it, all you have to do is say you're using Kohi, and that's it. There will never be any sort of royalties, no sorts of licensing fees or any of that kind of stuff ever on this. It'll always be 100% free. Any support that I get through like Patreon or YouTube memberships or Twitch subscriptions is just purely a way to support my work. It doesn't buy you anything, right? So I believe that education should be free. And so I provide all of this stuff for free. And so, that's basically more or less what we're doing, right? It started off as a YouTube tutorial series. We changed formats a couple of times because the tutorial series only really works for the basics. And then we evolved into eventually streaming on Twitch and YouTube. So that's just kind of where we wound up. And so we actually have a and I'll drop a link into the chat here for you guys. The Kohi engine website there is just sort of the central hub for everything. We do also auto-generate some documentation based on our code base. So if you want to, drill into this and figure out what some of these things are, you can actually take a look at the auto-generated documentation, and it has explanations of what all this stuff does and how it works, right? So there is that as well. And that's automatically done whenever I basically push to the main branch. So yeah, that is pretty much what we're doing here on the stream. You're working on a new 3D environment. That's awesome. So are you still playing around with different visual styles and stuff like that? Because I know you were kind of going back and forth on some different styles, trying to kind of find one that you liked. You love custom engine development. Well, good. That's what we do here. You found the right place. All right. So, in terms of what we were actually discussing for tonight, we were briefly talking about transforms and scene hierarchy. Now, this is something that's existed in our engine for quite some time now, but we're redoing it because I realized that there were some flaws in the way that we did it, right? And this is one of the things that we're doing on here is we're trying things to see what works and what doesn't work. And the current system we have now doesn't really work, so we're trying something else. Pretty much. Okay. Yeah. Awesome. Yeah, I'll have to check it out next time I see you online for sure. So, what I was thank you for the follow, by the way. So what we were talking about is essentially a lot of game engines today, especially ones like Unity, for example. That was the one I was using as my example. Sort of have this this hierarchy set up where you essentially have like a game object, right? That's what these squares are. And then those game objects can have sub-game objects, and they just inherit the transforms from their parents, and that's all well and good. But the problem with this arises when you have when you try to structure things in like folders, right? So you might have something like maybe you want trees to exist under this one. Maybe you want rocks to exist under this one, right? And so you don't necessarily need to move them together. You don't necessarily need these to have a transform, but every game object has a transform, and that's the way the hierarchy works, right? And so what you really might actually want is like, for example, maybe the only thing in this that needs a transform is like this rock, 0 or rock 1, right? Underneath of this guy, right? And so we might not even need the root node here to sort of have a transform. Maybe that's a folder, right? This guy doesn't necessarily need to transform. This guy doesn't necessarily need a transform, but maybe these two do, right? And so we should have that capability to be able to have things in a hierarchy like this, but not necessarily have everything be a transform. And so that's kind of what we're looking to achieve in conjunction with a system that we already made before, which deals with handles instead of using pointers. Let's see. Mefe Elite. Leaving it for the future, 3 a.m. in the EU already. Got to get some sleep. Take care. Well, thank you for stopping by. I appreciate that. For first time chat. And thank you for the follow. Appreciate that. Yeah, all this stuff will be available on Twitch for a bit as a VOD, but all of it's available on the YouTube channel, right? So, yeah, the whole series, in fact, is all on archived on YouTube, right? Okay. So, the way that we are going to attack this situation, right? Because we want some of these sort of nodes, you can think of them, to have transforms and some of them not, but still maintain their parent-child relationship, is we do away with this system entirely. And we actually set up 2 new systems. One for X-forms. We're just going to call them X-forms to differentiate them from our current transforms, right? So we have one for transforms, and all transforms are individual things, and that's it, right? So they know about a transformation, or translation rather, rotation, and scale, right? And that's all they know about. They cache their own matrix. They cache their own sort of local matrix. And I'm thinking we're also going to cache the global/world matrix as well, right? And so all the XForm system is going to have is a flat list of these things, right? They don't know anything about hierarchy. They don't care about hierarchy, right? Other than this sort of global cached matrix, right? And so the idea here is that all of these transforms or these XForms, instead of using pointers for these things, these all have an ID. And the ID is basically an index into this array, right? So this is basically an array of the things, right? And we just have indices into that. And so when we go to, say, set position on an XForm, we'll say set position on XForm 1, and it'll set it on this one. Or set rotation on XForm 4, and it'll set it on this one. And the only thing that we actually keep is the handle to the object. That way, if our XForm system gets full, our array gets full, and we need another one, we can actually perform a realloc on that, which could cause the address of this entire array to actually change, and we don't have to worry about that, right? Because that's all abstracted away and handled by the handle system, right? So we have our XForm system as one system. And then our second system is going to be our hierarchy system. And our hierarchy system is composed of nodes, right? And each one of these nodes can have children, right? Or more accurately, each node can technically have a parent, right? Is actually the way we store it in memory, right? So this top guy would have a null or a 0 pointer for its parent, right? Whereas this guy would point to 0, right? So this one would point up here. This would be 1. This would be 2. A badly drawn 2. And so forth and so on, right? And these individual nodes contain a couple things. So in each one of these nodes, they first off contain a handle, right, to an XForm. And that handle can be what we call an invalid handle, which means it doesn't point to anything. So this is how we get our node that could potentially point to an XForm, but potentially not, right? And so that is how we're going to address this issue right here. And then I'm still kind of playing around with this. We might also include a handle to the parent as well. The parent node, right? And so that's still a little bit that I'm playing around with. We'll kind of mess around with that a little bit on stream, but this is kind of what we're doing, right? Pocket Watch with a raiding party of 21. Wow. That's 3 raids in a row tonight. Awesome. Thank you guys so much. I really appreciate that. Pocket Watch, how was your raid? I hope it went well. What were you up to? Noto, hello. How's it going? Good to see you. Making a game. What kind of game are you making? I don't believe I am following you, so I'm going to do that. Speaking of which, I owe some people some shout-outs. I'm going to do it in the order that they came in. So I'm going to shout out Dino first. He was the first one to raid me. And I think I have to wait like a minute or so in between these. So Dino is another low-level programmer who is very knowledgeable and is doing some really cool stuff on his stream. So I definitely suggest you guys follow him. Co-op stealth, it's called Monaco 2. That sounds awesome. Well, I definitely gave you a follow. And I will check you out next time you are live, because that sounds really cool. Co-op games aren't very often made on stream, I feel like. So that's really cool. Are you using a particular engine, or are you rolling it from scratch, or how are you building it? I'm also going to give a shout out to New Jank real quick. Oh, wait a minute. I have to wait another minute. Okay. Twitch makes you wait before you can shout somebody else out. So I will give it in a minute. And I will give a shout out to New Jank. You're writing it in C++. Nice. Awesome. So I assume you're using like OpenGL or something like that, or... Very cool. NDBE, thank you for the follow. Appreciate it. Welcome. Okay. So while we are waiting on the timer for the shout out, DirectX Vulkan plus console. Sweet. I like it. We are eventually going to support multiple rendering backends for this as well. The first one is Vulkan, but we're eventually going to be supporting Direct3D and then Metal as well at a minimum. So that's cool. I would like to do consoles as well. At a minimum, the Switch, that should be relatively easy because it's Vulkan. It supports Vulkan anyways. But yeah, this engine is being developed with that in mind too. So it sounds like we kind of match up a little bit there on ideologies, which is cool. All right. Let me see. Is this going to let me do the thing now? So there is a shout out to New Jank. Definitely go follow him as well. He is a Godot dev. So he's working, I should say he's working with Godot, and he's doing some pretty cool stuff over on his channel as well. So if you're interested in that, definitely highly suggest you go and give him a follow. And Pocket Watch, I'll get you in just a second. All right, so what we've done since the last stream is we sort of started talking about our Xform system in the last stream, but we had basically an array of structures. And we've converted that to a structure of arrays. And the reason that we've done that is to have a little bit more cohesive memory layout in terms of when we are doing matrix multiplications and stuff, making things fit on cache lines a lot easier when we're loading data and looping through and updating the data. And this is true for things like positions, rotations, all of that, not just necessarily matrix math, but it'll be a lot more cache friendly for pretty much any of these operations that we do, with the exception of maybe actually building out the matrices, right? That's probably the only one that we won't really see too much improvement on. The other benefit of doing this, though, is it allows us to very easily sort of refactor the layout for this, right? So if we need to change the layout or change the way that it works, it makes it a lot easier to work with this way, right? So we're just kind of trying to focus on the actual data itself and the way that that's laid out in memory versus, trying to shove everything into structs and then just do it that way, right? The other thing is when we go to do SIMD, this is going to come into play as well. And the reason for that is because if we take a look, all of our, let's see, this is the shutdown. Where is the ensure allocated? So the ensure allocated is our alloc/realloc routine for this particular system. So in here, we go to the definition of that. In here, we are essentially setting up each one of our arrays using the allocate aligned procedure that we wrote. So we're aligning it to 16 bytes. We are aligning it to 16 bytes, and essentially what we're doing is we're doing that for all of these, right? Which we don't necessarily need to do for some of these things, but I went ahead and did it for all of them. That way, when we go ahead and put SIMD in here, it's not an issue. Vector 3s are going to need a little bit of work on that because right now they only have 3 elements, right? So they're going to have a fourth in order to work with SIMD, but that's a whole other thing. At least the memory for these will be aligned correctly for us to be able to actually handle SIMD. So that's kind of preparing for that as well. Let's see. Just want to thank you. I know a little bit, very little about C, and I want to create an engine and later a game. Your YouTube playlist has helped me a lot. I hope to catch up soon. Awesome. Well, I'm really glad to hear that. And as a first-time chat, welcome. And yeah, I'm glad it's helping you out. That's awesome. When you come to porting to Switch, are you going to use the Homebrew SDK or the real SDK? Only reason I'm asking is it sounds interesting to read through a Switch port, and I'm guessing you can't really open source. Yeah, so that's going to be the trick when it comes to consoles, right? I'm not going to be able to open source that code, right? Obviously, because there's NDAs, right? So the way that that's going to work is those platforms will essentially be a plugin that has to be licensed, right? And obviously you would have to also have an agreement with Nintendo or Sony or whoever we decide to port to actually get a hold of that source, right? I won't be able to release that open source. My hands are tied on that. There's nothing I can do about that. But for everything else, it will all be open source. You can open source it, but it has to be exclusively released on the Nintendo Developer Forum. Is that open source, though? And really, can you actually do that? I didn't think that they would allow that, especially Nintendo. Godot did it? Okay. Yeah, I haven't ported anything to the Switch yet, so I'm not familiar with the process yet. Okay. Yeah. So it might wind up being something like that, right? Like you have to have that license or have signed the NDA in order to actually get the source. I mean, I guess that makes sense. You've opted to port to both the official and Homebrew SDK for that reason. It's a lot more work. Yeah. I mean, but if I was scared of a lot of work, I probably wouldn't be writing my own engine anyway. But yeah, I get your point. Damn right. Exactly. All right, let's see. By SIMD, do you mean SIMD on the CPU? Yes, I do. Yep. Single instruction, multiple data. And we are going to be covering that here at some point. Let's see. Hey, just wanted to check in to wish you all a good evening, morning, whatever. Have a lovely stream, fellow Vulkan enjoyers. Well, thanks, Fixed Point. I appreciate that. Singy, hello. Good to see you. All right. So most of the changes that I made around the Xform system were all changes to make this more in like a data-oriented approach, right? So essentially, we've just gone and done that. The other thing that we did, and I'm still kind of playing around with this to see if this is the way I'm going to want to do it, is we maintain a list of dirty handles to transforms. So whenever we update, position, rotation, scale on a transform, that particular transform's handle index gets added to this dirty handles list. And then we, during an update loop, we can go through and recalculate all of those dirty ones, reset the list, and move on. So I'm not 100% sure I've got that logic right. So we'll have to play around with that. In addition, if we take a look over at the hierarchy graph, this is the other half of the thing that I've been developing that we were talking about, right? And so this is basically, looks like, I think I put some to-do type stuff up here of how I was thinking about doing this. But essentially what this does is this just represents the sort of scene graph view that you might think of when you think of a hierarchy, right? So like this, essentially. This is what essentially we're talking about. So if we take, let's see. So our graph itself is also sort of following a data-oriented approach, right? And so we have a list of node handles. So each individual node within this graph has a handle to it as well. And then we have a list of parent indices. So each node has a handle to it, a parent index, which could be either an index to a parent that's in this array, or it could be an invalid ID, which would say basically it doesn't have a parent. We also keep track of a level, which is basically how far down it is into the tree. I may or may not keep this. This may only be useful for debug building, which is why I put this this here. I'm not 100% sure I'm going to keep this, but it's a good sort of visual to say, okay, how far are we into the tree? We also have flags to mark nodes as dirty. I'm not currently using these yet, so we're going to have to play around with that to figure that out if we need it or not. The other thing that we have is we have XForm handles, right? So we have node handles and XForm handles. And the difference between these is this handle is a handle to an XForm. It can be an invalid handle, which means this node doesn't have an XForm. But it could also be adds, because Bezos has stepped in and given us adds. So for those of you who are new to the stream, we like to pause the stream whenever ads come up so that nobody misses content. And of course, all of you folks over on the Twitch side that are getting these ads right now might not be able to hear me, so I'll repeat this again when the ads are finished. For those of you over on the YouTube side, I know that ads work a little bit differently for you guys, so we are not actually... I'm not 100% sure how they show up over on that side just yet, but yeah, basically the idea is that if we're running ads somewhere, I want to pause the stream, right? We want to keep people from missing things. All right, so we've got about 45 seconds left on ads. So I would say, if you haven't already, hydrate. Almost done with ads, and then we can continue. All right, and we are done with ads. Ads are dead. So for those of you who are new to the stream, what we do is we pause the stream whenever ads come up. That way nobody misses content, right? So we can have up to 90 seconds of ads every 30 minutes. I like to pause the stream for that. That prevents us from having pre-roll ads, but also keeps you guys from missing anything behind ads, right? So let's see. Is there an official channel for Kohi website bug reporting, or shall I just shell one out right here? So if it's a bug with the website itself, you know what? I don't have an official channel, but so that it doesn't get lost, I would say hop over to the Discord server, because we do have a Discord server. I think the link to it is in the description. Hop over on the Discord server in the Kohi channel and just ping me, just at me in there so I see it, and just let me know what it is, and I can fix it. It's not surprising that there's an issue with that. I should probably come up with like some sort of official channel for that, but I don't have anything for the actual website itself. Even the streamer takes ad breaks. I like that meta. Yeah, exactly. I try to, you know, just because with a programming stream, like, it sucks to miss an explanation because you're covered by an ad screen, right? Okay. So I think where we were is... So node handles are handles to the node itself, whereas a XForm handle is a handle to the XForm if that node has an XForm, right? And then we have something here called the hierarchy graph view. And this view is a little bit different. This basically takes all of this information and composes it into a structure, essentially a tree structure. That we can then use in other parts of the system to act as a view of what this thing actually looks like, right? So that we don't have to go querying all these handles and stuff like this to figure out what the actual structure of the tree is. We can actually just look at the view. So the view right now is just a structure that holds nothing but root nodes for right now. And the root nodes can obviously have children, right? So we have this special structure here, which is a hierarchy graph view node, and essentially the way this works is like a standard tree would, right? So we have a array of children for each node that could be 0, essentially, if there are no children, or it could be populated with children. And so what we do is once every update, we build out one of these, and it is available for us to query if we need to. And then on the next update, it's torn down and rebuilt again, right? Which sounds like a lot of work, but it really isn't. The other thing that we're going to use this tree for is we're not just sort of using it for external purposes. Is we also use this to very quickly go through and traverse the X forms, so that we can build out all of those global transforms. And so that's kind of the dual purpose behind that there. Again, we're trying this out to see if it works, right? And so there's some notes here that I have about some things about, like, some of this stuff should be internal, some of it should be external. So we do have a little bit of refactoring work to think about there, but more or less this is kind of the direction I'm thinking of going in. Let's see. Dumb question, but what vector operations are you actually doing on the CPU? Is it all the transforms? By vector operations, are you talking about SIMD vector operations? We're not doing them yet, but that's the idea. Basically, we're going to do those on anything that's a matrix, and then vector 3s and vector 4s, essentially, if that's what you're asking. Okay, cool. So let's, I pretty much have the implementation of this complete, I think. So actually I was kind of getting to the point where I was ready to start putting this into the scene and start using it. And this is really good. What's going to be sort of the determining factor is if we've done it correctly or not. So let's go into the scene, and we'll go into here. You know what, actually, before I do this, before I actually break the code, I should probably run this so that you guys can actually see what we have so far. So let me do that, because I know there's a lot of people in here that are new from the raid and whatnot. So all the things that I've written here are new. They don't touch anything in terms of existing code. So this does actually still run. So I'm using this editor just basically as my my debugger for right now. And so when I run the engine, right now we're presented with this, which basically means we don't have a scene loaded, right? We've just got some basic UI stuff here. If I press L to load a scene, this is what we have so far, right? It doesn't look like a whole heck of a lot. And I suppose, visually speaking, it's not, but there are a lot of systems at play underneath this. So what we have is we've recently put in a PBR pipeline, rendering pipeline. And so that is what we're using here. We have cascading shadow maps as well. And so these were just a couple quick test objects that I put out here for that. And then, of course, we have our very well-known Sponza scene in here. And so if we take a quick look, we also have some debugging render modes. So we have like a lighting-only mode that shows us, just the lighting, normal maps, shadows, things like that. We have a normal mode, so we can see the actual normals of our meshes, right? Same thing goes for out here. And then we have a shadow map cascade view, which basically just kind of splits out the shadows for us so that we can see where those different levels of detail are there. And so we have the, let's see, you can actually see all 5 levels here. So we have red, which is the highest detail, then green, then blue, then yellow. And if we go up a little bit, you can see that there's also a vast white area. What that basically means is that the shadow map itself fades out at the end of this yellow area. So if we actually, if we take a look down here by the corner of this building, as we move away, you can see there that it smoothly fades out, right? And so that smooth fade ends where that yellow line is, right? So it's just kind of a couple little debug views, right? And then we also have a wireframe view as well, where we can see our terrain and our terrain's level of detail where all the chunks sort of render at lower levels of detail than distance, things like that, right? Wouldn't be a test bed without a Sponza. Classic, exactly. Exactly. And so that's the reason I chose this is because all of the meshes that are in it are separate. So it allows me to sort of do something with a high number of draw calls, right? So we don't have one thing that we're missing is we don't have occlusion culling or occlusion queries or any of that kind of stuff in here yet. We do have frustum culling. So if I turn away this way, you'll notice that the drawn count goes way down, right? Terrain meshes are included in that. So, we do have frustum culling that works, but yeah. So we have all kinds of systems in and running. And now we're just kind of doing something that I probably should have done at the very beginning of the engine. And this is one of those things like in retrospect, you just kind of learn along the way, right? So, I think, we should be able to use this decoupled hierarchy graph from our X-form system, and we should be able to use the combination of those to be able to achieve what we need to achieve in our scene. So, our scene right now is, and this was kind of something I was playing around with here, and this is kind of what led us down this rabbit hole, is I was like, well, maybe we have scene nodes of different types, one for each kind of known type, and then we have a name for that thing, and we have an identifier for it, and then I just got thinking about parent-child relationships and that kind of stuff, and I'm like, we should actually have a proper system with proper types for this. And then that got me thinking about handles and not using pointers and pointer chasing all over the place, and we just kind of went down the rabbit hole. So now we're climbing back out of the rabbit hole, as it were. Let's see. You meant vector 3, vector 4 operations. So what vector operations are we actually doing for vector 3s and vector 4s? On the CPU, I mean, we have your standard, add, multiply, subtract, divide, right, for moving things around, translating things of that nature. So we have those things. That's probably the most common is transforms for right now anyway. We do use, on occasion, we use vector 3s and vector 4s to represent colors as well. That's kind of a temporary hack, but it's mostly transformations at the moment. Okay. So I don't think, let me see. I don't think we are actually using the scene node anywhere yet. No. Okay, so I'm going to kill this because it's not what we need. And I don't think I'm going to need this either, but we'll see. I'm going to leave it in here for, actually, you know what? Let me leave this in here for right now. But is this needed? Let's at least put some notes on these things so that we know to come back and get after that later. All right, so if we take a look at the scene structure, the scene structure right now basically has direct pointers, or I should say arrays of things, which we then use pointers of to sort of grab the data out of these things. So for example, we have a scene transform, right? We have directional light, point lights, meshes, and then in the mesh itself, the mesh actually has a transform, right? And so this is definitely not ideal, and this is what we're trying to get away from. And so the first thing that we need to think about is I think it's okay for the scene to own these for right now. Maybe not. Actually, probably not. These should probably be owned by systems, right? So that way those systems can perform just mass updates on the things and we can kind of split them out. But we have, actually, this pending mesh thing isn't even used, so we can get rid of that. We have a pointer to a single skybox. We have things in here like debug grids. These things should all be sort of attachments to these nodes that we have. And so right now, when we actually are figuring out, our hierarchy, let's see, where was that? When we're figuring out our hierarchy, we're sort of going through all the properties of each of these individual objects, specifically meshes. And we are actually, I believe we had like a parent name in here, I think. Yeah. We're actually looking for something called parent name. And then we're taking that parent name and searching to see if that thing actually exists. And if it does, then we go ahead and parent its transform, right? So we're reaching into that object and parenting its transform, and that's a terrible, terrible hack. And so that's basically what we're trying to get away from doing. So my thought process is that we have this system here, right? Where I'm going to expand this, right? So this is going to be over here, right? So this is our node. This is our node. And our node has, oops, I wanted yellow for that. Our node has a handle of its own, right? So, essentially an integer that represents it. It has what did we say? I think we said does it have a... The view node, rather, has a parent, right? Or was it children that it had? I went back on this a couple times. Hierarchy. There's a list of children. Okay. So it has a list of children, right? So that's a whole other thing, right? And these children, though, are just nodes. Right, so each one of these guys are just nodes, right? And so what I'm thinking is there are two ways we could sort of attack this issue, right? Because what do these nodes actually hold, right? They have a transform, but we also need something else, which I'm thinking we call attachments. And the attachment could be like a mesh, right? Or it could be a terrain, or it could be a skybox, could be whatever, right? And we can have an array of attachments, and maybe there's an attachment type, right? And the attachment type is like a known type, and that tells us what kind of type it is. Maybe we handle it that way. I'm not 100% sure yet. So this will give us a sort of a way to extend this node structure in a way that is flexible and should hopefully be easy to understand and work with. But we can also treat it in a sort of data-oriented way where it's quick to update, right? Where we can sort of churn through a huge list of these things and update them accordingly. So when we start talking about the scene, we need a way to handle that. So the question becomes, do we hook it to the graph node, right? And maybe we just add handles to those things. Or do we do it some other way, is the question. So this is kind of the experimentation we're going to be doing tonight. So let's see. We have, if we do it here, then that means we're going to have to know about this information somehow, right? The hierarchy graph is going to have to know about it. So I'm actually thinking it probably doesn't belong on the node, right? Maybe the attachment has a node, a handle to the node. Right? Maybe that's the way that we do it. Because we have the hierarchy, and then we say, okay, we have maybe a flat list of attachments in the scene. And maybe we have mesh attachments and terrain attachments and stuff like that, right? So we have flat lists of each of these attachment types. And then the attachment can then have a node handle. Then we can use that node handle to look up the node to get its transform or anything else we might need. It seems like the most decoupled way to do it to me. So let's see, do we actually want to do this in, where do we want to represent this? So we actually might need these scene nodes, right? Except we're going to call this let's call this do we want to call it hierarchy node attachment or just attachment node type? Maybe. Let's go with attachment node type. So maybe we have a scene attachment. The attachment, we don't need this actually. Okay, I just answered my own question. We don't need this stuff. So we don't need the attachment type. What we need, and this actually probably shouldn't even be here. This should probably be in the header file. So we have scene attachment, and then we have flat lists of attachments. And the attachment is what actually has a handle to the node and a handle to the resource that it's attached to. So it's basically like a lookup table almost, kind of like. I think that makes sense. So if we do, oh, we have this pending mesh thing here. Let me get rid of this. We don't need that. So if we do K handle, and we'll call this hierarchy handle, hierarchy node handle, and K handle do we want to call it resource? Resource handle. I think that makes sense. Need to include that. All right. So what we're going to do is we will say scene attachment. It's going to be an array of those. And we'll say, for example, mesh attachments, right? And each one of those can be linked to a handle on the node tree as well as, okay, yeah, that makes sense. So that way we can say, okay, well, we need to get all of the mesh attachments, or we need to get all of the terrain attachments. So we have scene attachment, terrain attachments. Why do I have to use the struct? Oh, because I didn't rename this. feel like this makes sense. I just really am wondering if these attachments should exist elsewhere, but I'm going to do it here for now. All right. So the scene transform, I don't even think we're using that. So I'm going to actually nuke it because we don't need that. So the first two things I'm going to move are meshes and terrains. We're going to rework those first because these other types are going to be a little bit weird to rework. Because the way that they kind of store and represent data right now is a little bit strange, and we kind of probably should refactor some of those things. But meshes and terrains should be doable. I think terrain also has a transform. It does, right? So we need to actually remove that as well. Okay, so let's actually just do it, right? Let's do removal of the terrain transform and the removal of the mesh transform. Right? Done. So in order to render these now, we are actually going to have to use our new systems. So how do we then handle this? I think the first thing we're actually going to have to do is scene initialize. Let me see. Scene create, actually. We don't have the scene transform. We can get rid of that. What we're going to have to do in scene create is, let's see, we're going to create our internal list of renderable objects. We're going to internal lists of attachments. So we got to create those first. So we'll say out scene. We'll do mesh attachments first. Equals darray create, and this is going to be a scene attachment. And then we can just do the same thing for terrain attachments, right? And obviously we'll add the others later. Okay, so here's our debug grid kind of stuff that's set up. Eventually we're not going to want to do that there either. So when we initialize, so this is header level information. This is the skybox, directional lights, point lights. Those are all fine. So meshes. Okay. So here's where we need to actually create some nodes. Although I'm getting ahead of myself because there's actually a little bit more work that we need to do. Let's see. So in scene create, we create our initial list of attachments. We also need to create a hierarchy graph. We actually don't have a spot on the scene to store that, so we actually need that. So let's just put this towards the bottom. Hierarchy graph. And the scene's going to own that, so we're going to have to anonymous structs, our Microsoft extension. What? Oh, right. Okay. We're just going to call this hierarchy, right? So we'll do the address of out scene hierarchy. All right. So this technically can fail. So we should do a check on that to ensure it doesn't fail. Failed to create hierarchy graph. Oh my god, I keep hitting the wrong keys tonight. All right. And we have ads. So for those of you who are new to the stream, we do pause for ads. For those of you who can hear me anyways, we do like to pause for ads so that nobody misses any content. I know on the YouTube side it works a little bit differently, but on the Twitch side, we do get ads every 30 minutes for 90 seconds. So I'd like to pause during that. And I would also like to tell you guys, if you haven't already, definitely hydrate, right? And in addition, I am trying to actually grow these channels on both sides. So if you guys haven't already, I would encourage you to follow. I would greatly appreciate it. It'd help me out a lot. Thank you for the follow. Appreciate that. So we got about 30 seconds left on ads. Almost done. All right. Thank you for the follow. Appreciate that. All right, so just a quick recap. So for those of you who were blocked by ads during my explanation, I like to pause the stream whenever ads come up, which is once every 30 minutes for 90 seconds. That way you guys don't miss any content while ads are rolling, right? Because I think that sucks. So just to kind of prevent that from happening, I pause the stream. I always take it as an opportunity to hydrate. I think you guys should probably do the same. So it gives you guys a second to get up and get some water or something too, right? So let's see. Not exactly sure the contents of your out scene. Good evening. In the past, I've used an array of arrays. I mean, you could do it that way, right? And rather than naming the lists, I use an enum to label the lists. That's one way of doing it. I find that this way of doing it is pretty self-explanatory. This way, I don't have to like switch on what type of attachment we're talking about. I could do that by just accessing the different list. So, you know, you could definitely do an array of arrays on this if that's easier. I just think that this way it basically comes out to be the same thing in my head, right? I don't think you gain or lose anything by doing it either way, to be honest. Just different ways of doing the same thing. But you bring up a valid point. That is a way of doing it, right? So, okay. What did I do here? Oh, that's wait a minute. No, that was correct. This should be an arrow. There we go. Let's get rid of those highlights. Okay, so we create our hierarchy graph. We're not going to create like a root node or anything like that, because essentially anything that we add to our scene that doesn't have a parent is going to be a root object. The advantage of doing it that way, FYI, is if we have lots of roots or lots of deep hierarchies, for example, we can actually split off by the individual roots. We can actually split those to like multiple threads and actually update those that way, right? Because of the way that we've structured our data, we could actually multi-thread updates on this if we ever needed to, right? I'm not going to do that right now, but it lends itself really well to that model because of the way that we've actually done this. Okay, so we have hierarchy graph create. Is there anything else I need to do? I don't think so at this level. I think the other stuff comes from actually loading in components or the different. I say components. It's not really components. It's like meshes, right? So for a mesh, let's see. We have a mesh config. We do take the parent name, take the resource name. So this whole aspect of the parent name is something that's got to go away. Because what we were doing before is we were basically just looking these up by name to parent them. And then if it didn't exist, we'd bleat about it, right? But we don't really need to do that anymore. We really should have, for all of these individual objects within the scene config, we should have the ability to actually create parents and children, which we don't. And we were talking about having a little bit more of an expressive language behind that. So that's something we're going to have to do too. To show you guys what I'm talking about. So we load up a scene file. This is what a scene file looks like currently, right? So we have some header level information here that's got like version in there, name about the scene, description, things like that. And then all of our individual sort of items look like this. So this is a skybox, this is a directional light, this is a mesh. And then each of those things obviously contain a name, a resource name, which is how we load the model, and then a transform. And so we had the ability in here, and I don't think we actually have an example of it currently, but we had the ability to essentially do this. Like if we wanted the tree to be a child of Sponza, they would essentially say parent name equals Sponza, right? And that was all well and good for our simple testing purposes, but we need something that's a little bit more expressive, right? We actually need a way to sort of nest these objects, right? So I'm going to do away with the parent name, and we're going to kind of handle that a little bit differently. Let's see. I kind of agree. The only thing I like is you have a single enum that describes the passes. Yeah. Kind of cool. Have you looked at Scheme? I have not. No. Heard of it, though. Just not looked at it. So yeah, we're definitely going to have to do a little bit of rethinking on how we handle this file. And now that I'm thinking about it, we kind of need our configuration to be set up to handle this, right? Because we don't have enough information in our sort of mesh config thing here to actually determine how our hierarchy is set up, right? So we actually need sort of a tree view like what we have in our hierarchy graph. We need something like that that we can read in from our file. So that gets a little bit tricky once again. So there's kind of a bunch of moving pieces here, right? You're building something similar to me, but you're using C++ and Vulkan. Nice. Are you doing that on Streamlisp, or is it just sort of a repo that you're kind of working on? So now I'm thinking there's two ways we could attack this. We could go and fix the configuration and figure out the hierarchy behind that, and then come back and do this. Or we can just assume everything is a root right now, add it as a root, and then go back and fix the configuration and then make that so it's nestable. Not 100% sure which way I want to proceed. I'm thinking about that. I suppose we could take a shot at I feel like doing this section twice is kind of dumb, right? We should probably get the config straightened out first before we do this. I'd hoped to jump into this tonight, but I don't think that's the smart thing to do. You built it from the ground up to run threaded distributed. Nice. The idea is to stream at some point. You have around 75% of the code you've written compiling on Windows Linux, Mac. You work on Mac mostly. Nice. That's pretty awesome. Yeah, so unfortunately, like, I think if I were approaching this from a different angle and not trying to do it as sort of a educational resource where I had to sort of cut corners to simplify things in the beginning, I probably would have done the same thing from the get-go. But because I was trying to sort of, especially in the beginning, because I was trying to stick to a tutorial type format, it kind of forced me to go into a simpler direction on things where I'm kind of now paying for it. Lesson learned there, right? All right, so I guess let's look at where is this? Scene config is in scene. All right, perfect. So we're already in scene H. So let's go to the scene config and knock this out first. So this is a little bit weird the way that we have this. And again, this was sort of something that I shortcutted to kind of get something done and working, but we kind of need to rethink how we do this. So our scene config has our sort of header level stuff up here. We have a single skybox config, a single directional light config, which I think both of those things make sense. You really only are going to want one of those per scene, I think. Maybe not, though. And then an array of point lights, an array of meshes, an array of terrains. So this is pretty flat, right? It doesn't sort of contain any sort of structure that we can actually use. So maybe we do. Maybe we rename this one, right? And we'll do a type def struct, and we'll do scene config. If I can type. All right. And to the scene config, we are going to a couple things that we can keep. So we want the name and description. That we can keep. That's sort of header level stuff. Let's also include a U32 version. We weren't really doing that before. We should probably be doing that now. And then we'll start thinking about nodes, right? So we'll do type def struct scene node config. Scene node config. So each scene node is going to have a name. We're not going to do anything like IDs here, right? Because those are sort of loaded on the fly and will be generated at runtime. So we're not going to do that. We're going to have a name. And then we're going to have scene node config children, right? And then we also need scene attachments, right? So we need scene, type def struct scene node attachment config, right? Scene node attachment config. I suppose this could also have a name. Maybe those names are only in debug builds. I don't know. We'll have to figure it out. And then the real question is how do we get these different types of information there, right? I mean, we could do a union but that seems kind of gross because our sets of data are different for all of these things, right? And so our size requirements are going to be different, and if we do a union, it's going to be the largest of that all the way around. So our memory bloats out, and that's kind of gross. So my first thought is we might actually take a page out of the Vulkan API for this. So let me go to the Vulkan backend to illustrate what I'm talking about. So a lot of structures in Vulkan have this S-type in the actual structure, right? So a lot of our structures, if I peek definition on this guy, you'll notice for these things, the first thing in this is a VK structure type, right? It's the very first thing. And the nice thing about this is that basically the driver can take whatever struct you pass in here, cast the entire struct to a VK structure type, right? And essentially get the type out of that, and then do another cast to the actual structure type based off the S type. So that's actually what I'm kind of considering doing. I think that makes probably the most sense, is just doing something like this, because that way we know what type it is, and maybe we just include like a pointer to that thing so that we don't have to have, you know, a weird union. That's what I'm thinking. Let's see. The core is designed to be a persistent distributed. I want to be able to get to the point where people can drop in and out of the world with a client before starting to stream. That would be neat. Yeah, that would be really neat. I understand the idea of building for a tutorial and keeping the complexity small. Exactly, yeah. Unfortunately, it adds complexity later, which is what we're dealing with now. Written a lot of OpenGL and just starting to build the layers and layers. That is Vulkan. Yeah. I mean, my Vulkan backend right now is 4,000 lines of code, but there's about maybe 8 or so hundred lines of code and a couple of other files. So yeah, it's not terrible, but it's not great either. Once you get past the boilerplate stuff, it's actually really not that bad. Like, I know people are like, oh, Vulkan, it's 1,000 lines just to draw a triangle on the screen. But once you get past that, though, like, adding new stuff is generally not that hard. Okay, so if we do this, so we have scene node config. This needs a struct tag there. So we have attachment config. So we have the attachment, and then we have we'll just call it attachment, right? A void pointer to attachment. And that void pointer will have a structure that contains something out of this enumeration. So it'll be, we'll call this scene attachment type. Actually, this should probably be scene node attachment type. Right? And so this is where we'll do sort of the thing that we had before. Did I nuke that already? I probably did. Did I nuke it? I think I did. Yeah, whatever. Doesn't matter. I can retype it just as fast. All right. So what we'll add here is we'll just do the two that we're working with right now. Let's do scene node attachment type unknown. And we'll do that as the first one, which will be equal to 0. So that'll be our default. So we have to explicitly set this. That way we don't wind up having some sort of default type that gets passed that we don't know what to do with. Or causes errors that aren't immediately obvious. So attachment type. So we'll do, I'm going to call this static mesh because this is another change I plan on making. Thank you for the follow, by the way. Appreciate that. All the follows, in fact. I appreciate that. Let's see. You have a lot of other code. There's the start of networking. There's a script system with a VM waiting for a compiler. An ACID transactional database. Yeah, you've got a lot then. But yeah, 300 lines of Vulkan hasn't taken you far, and it won't. You need about 700, I think, to get something on the screen. All right, so we'll do. We're eventually gonna call meshes static meshes because we are gonna have what we're gonna call either an animated mesh or a skeletal mesh. I haven't decided yet, but what we have now is a static mesh. So we're gonna rename that at some point very soon. So attachment type. We're going to do terrain. Right? And we'll add more to that as we support them. But for right now, that is what we are going to have. So the way that this is going to work is similar to the way that the S type works in Vulkan. We are going to do type def struct. And we'll say scene node attachment. And then we'll do static mesh. Scene node attachment static mesh. Right. Thank you for the follow. Appreciate that. Welcome. And so the first thing that we're going to have here is we're going to have the attachment type, right? And that's going to be a scene node attachment type. And then we can kind of fill out our other stuff, right? So let's see, we have attachment config. Yeah, I think that makes sense. Okay. So our attachment config would basically take one of these like static mesh things. So we have our terrain config here, right? So we might have something that looks like this, right? But we're going to change this up a little bit. So we already have the name on the attachment itself. So we already have that here. The resource name will be part of the attachment. The transform will not be here. The transform will be on the node. And this is more of like a transform config, right? We actually don't have that yet. We need a way to parse that data. So our scene config, to recap, our scene config is going to have a essential hierarchy of nodes. So we'll have scene node config, right? We're just going to call this nodes. Right. So our scene config has a list of nodes. Each node has a name. A transform, potentially, right? That could be undefined. And then it can also have children of scene nodes, right? That are scene nodes themselves. And then each of these can also have, maybe the attachments what should have Should attachments also have a transform potentially? Maybe. So here we'll also have in the node config, scene node attachment config, attachments, right? So each node can have a name, a transform, attachments, and then children. So children are just more nodes, which can also have more attachments. Theoretically, you could have a scene node that is only named, not have a transform, not have attachments, and not potentially not have children, right? Or maybe it only has children, right? In that case, you're using it kind of like a folder, right? So that's kind of what we're hoping to achieve there. Also, to do make optional. All right, and so in our attachment config, the attachment itself has a name, and then a void pointer pointing to a structure whose first member should be the scene node attachment type. That attachment type will tell us what type to cast to. So we have like static mesh here, which of course this only contains a resource, I think. I thought there was more in here than that. Maybe not. Nope. Okay. So mesh and scene config are pretty much the same thing for right now, but they may not always be. In fact, I know they won't always be, because we're eventually going to have more properties available as well. So we have this attachment type, and then we'll also have this. So we're going to do, instead of static mesh, we're going to do terrain and terrain. And again, these structures are identical for now, but they won't always be, right? So terrain, attachment, and static mesh attachment. And then by whatever this attachment type is set to is how we'll know to cast. So that, I think, covers what we should need. So this entire structure, this is basically what we're going to build out when we read the configuration. So we might have to, like, to get this working, we might actually have to kind of hack one of those together in code, and then rewrite our parser to actually be able to parse in a way that we actually get this structure. Okay. I suppose, actually, since we've kind of figured out this memory and structure issue here, we could actually specify these other types of attachments, right? So we could have a skybox, directional light, point light. Let's go ahead and I'm actually just going to copy these for right now. And we'll come down here and just sort of redefine these as attachments. So we're going to call this scene node attachment skybox. Scene node attachment skybox. Right. So we don't need the name here. We only need the attachment type and the cube map name. This one is going to be, let's actually just do this to kind of visually split it up a little bit. Skybox attachment. So actually the skybox is actually a really good example of something that doesn't need hierarchical transform information, right? The skybox doesn't really have a transform. Its transform is the identity transform. So when we would go to set this one up, we would basically just say we have a node that's called skybox that has a skybox attachment that has this cube map name, and that's it. No transform provided, right? No transform needed. That is an example of one that we can definitely do that for. Thank you for the follow. Appreciate that, by the way. So we'll say scene node attachment, directional light. Okay, so that should be good there. We don't need the name because that's already in the attachment. So we have directional light attachment, and we also have ads. So for those of you who can still hear me, I would suggest you guys take, you know, a quick 30-second break. Go get some hydration, right? We like to pause the stream so that nobody misses any content, right? So we've got about 45 seconds left on ads. And then we will continue. Almost done with ads. All right, cool. Ads are dead. So for those of you who are new here, I'd just like to pause the stream whenever ads come up on the Twitch side. We're served with those every 30 minutes for 90 seconds. So I'd just like to pause the stream so that nobody misses any content, right? So yeah, if you guys need, that's a great opportunity to you know, get some hydration. It's always a good thing, right? Having some green tea, not the greatest idea before bed, maybe. Isn't green tea like packed with caffeine, or is that matcha I'm thinking of? Which I guess is green tea, but yeah. Also, first time chat, welcome. Glad to have you here. All right, so this is our directional light attachment. We're gonna do one more for the point light. Node attachment, point light. We need to get spotlights in at some point too, as well as area lights, but we don't have those yet. So we're just doing this. Okay. One reason I was saying that these need a little bit of refactoring as well is because things like this directional light, we have direction, right? So we could technically derive this from a transform, and it might make it a little bit easier to actually edit in the scene. So we may wind up actually changing that at some point. And then also the point light has a position in it as well. Instead of direction, it has position. And then a spotlight will have direction and position, right? So we should probably be using transforms to get some of this information, but I digress. Let's see. Something similar to caffeine, yeah. Or I assume you mean coffee, yeah. Probably not the best idea before bed. That being said, I know I've done it a number of times, right? Okay, so we actually need the attachment type for these guys as well. So we just need to jam that in there. Okay, so we have point lights, directional lights, skybox, terrain, and mesh, static mesh. So we just need to add scene node attachment type. I'm just going to paste this in here a couple times. And then we'll do skybox, and then directional light. Oops, if I can spell it correctly. And then point light. Right. So now we can look at the attachment type and go from there. And we can actually just simply get that attachment type by casting whatever structure it is to scene node attachment type and getting it that way. Right. So I think we have everything we need here to sort of set up our processing logic over on the scene side. So I think what I'm going to do is basically everything past this scene config I'm going to split out, I think. Let me just remember, because I know we have an initialize and a load step here. So the initialize, I believe, was just setting up, copying over our data structure values. Yes. Okay, what about transforms? That's the only other thing I can't remember. Do we do transforms here? We do actually, oh, we do mesh create here. Interesting. And we do transforms here. Okay, so for the initialize, we essentially get everything prepared to load the asset, but we don't actually load the asset, right? We just kind of prepare all of the configuration data that we have, set up the nodes, and so forth. So what I'm thinking here is if we take a look at the scene config, we've already handled the name and description. That can stay the same. The nodes are what we actually need to differentiate on. So I think the nodes, we're going to create this as a D array, and we're just going to do that to keep things simple. We're also going to do the same thing. We're going to do the same thing for attachments and children, right? That way, if we have to add things to it, it's just real easy. We don't have to worry about it. So what we're going to do is we're going to say if scene, whoops, if I can type, if scene config, you know what, do I really want to do scene config pointing to it that many times? Let's do this. Let's do scene config config equals the address of scene config. That way I don't have to type that stupidness over and over and over again. All right, so now we can say config. So if we have config.nodes, right? So if that exists, then U32 length, actually let's say node count equals darray length config nodes, right? And then we'll iterate the nodes. U32 I equals 0, I is less than node count plus I, right? And then from here, we actually need to handle this recursively. So what we should probably do is have a recursive method that takes a pointer to a node and then processes that node, processes its attachments, and then sets up a loop to process its children, passing a pointer to each one of those children to itself. So here we can say, let's return type Boolean, right? Because we could have a failure here, although I don't see that happening. In fact, yeah, for initialization, I really don't see that happening. I think we can do return type void on this one. We'll say scene node initialize. And what we'll do is we'll take a pointer to the scene, And we'll take should we take the whole scene config? I don't think we're going to need that. I think we only need the node. Scene node config node. All right. So the first thing that we can do from that node, let's see, we should go ahead and grab its name, right? So we can say, I'm just going to copy pasta this, and say if node first off. And then if node name, and then this is where we're going to actually start creating our hierarchy, right? So let's take a copy of the name. I don't know what I'm going to do with it yet. Let's do a hierarchy graph. Root add. Oh, you know what though? We can add this with an X form. So we should probably see if we have an X form first. Which we have a to do here to make that optional. How do we want to handle optional? And first off, we shouldn't be using a transform. We should be using an X form anyway. But we could have an X form config. Maybe that makes sense. All right, so let's think about that for a second. So we have type def struct scene xform config. Scene xform config. And I think the only thing we really need is I think we just need our vec3 position, quat rotation, and our vec3 scale. Right? I think that's really all we need for this. As far as how to make it optional here, how do we want to do that? I don't really want to have a pointer to it, right? That seems kind of weird. But maybe that is what we do. I mean, technically speaking, this loading code is, or this initialization code only happens when we're loading a scene, right? Which needs to be quick, but it doesn't have to be runtime, middle of the frame quick, right? So I'm thinking it should be fine. Like, I know it's another dynamic allocation, but I'm kind of fine with it, I think. We're going to do it that way for now. So let's do our transform config. Let's do scene xform config, and we'll do a pointer, right? Pointer to a config if one exists, otherwise 0. I ordinarily would not do that in a lot of my data structures, but since this is only a config, and it's only used during scene loading, and then it gets thrown out right afterwards, I think I'm fine with it. Okay, so that would mean if node xform to do parse xform. We don't have logic for that yet, so we'll have to come back to it. But let's do we can actually call two different functions here. So if we have an xform, we can then say hierarchy add with xform. So we need the graph. So that's going to be the address of scene, or the address of S, rather, hierarchy. And then we need a handle to the xform. So we actually need to create an xform. So we need to do xform from rotation, position rotation scale. So we'll say node, wait a minute, node xform position. Node xform rotation and node xform scale. All right, what that'll give us back is a handle. So k handle xform handle, and then we pass that to this guy, right? So the parsing of the xform is actually not going to be done here, because by the time we get this xform config, it will have already been parsed. So we could just pass that through. If we don't have an xform, then we can say hierarchy root add, and we just do the address of S hierarchy. Oh, this needs to be config name. Where's it? Node name. There we go. Oh, and these don't belong. Whoops. These don't belong in this scope. They should be here. Okay. Okay. So, oh, you know what? We're adding a root. We don't know that it's a root. We don't know that it's a root. Okay, so in this case, let's see. We actually need to do this a little bit differently, because we could be dealing with a root node, or we could be dealing with a child node. The child node always takes in. So if we have these two variants here. We have this hierarchy root add and hierarchy. Oh, I don't think you guys are going to be able to see that. I think it's behind my camera. Right, so we have graph root add, which just adds a node without a transform, and then we have a variant of that that adds with a transform, and then we have a child add without a transform and a child add with a transform. And the only difference between these two is the child add takes a parent handle, which technically speaking, we could just pass an invalid handle as the parent handle and accomplish the same thing. So actually, we should probably be using child add regardless instead of the root add, because the root add calls child add anyways with an invalid handle. So let's do this then. We'll say, let's cut this and put it here. Right, and then here we'll say xform handle is equal to that. Take this guy, move him down here, remove that, cut that as well, and then we'll say add child, right? Passing the xform handle. And then we'll also take in a scene parent. So we'll do a scene node config parent, right? We'll pass that in as well. And here we'll say if parent then we should be able to do, we don't want the parent's config, we want the actual parent's handle. Thank you for the follow, appreciate that. Welcome. I should say thank you for the subscription over there on the YouTube side. I keep saying follow, but subscription is different from on YouTube and Twitch. It's weird. Okay, so let's do, instead of this, we should actually have a K handle here. So we'll call this parent handle. And actually, we don't even need to check that then. Then we could just say parent handle. And if we're at the root level, then what we will wind up doing is pass an invalid handle as the parent handle, and that'll basically say we don't have a parent. So we add this to the hierarchy, potentially having gotten a xform first or not, right? We add that to the hierarchy. This also returns a handle. So we want a K handle. And we're going to call this node handle. And we should probably also say here, if we don't have a transform, we should say xform handle equals invalid. What is it? K handle invalid? There it is. K handle invalid. Okay. Okay. So one way or another, we get an xform handle. We then use that xform handle, potentially the parent handle. We create the hierarchy node. And then we should be good to create attachments based off of that. So let's just kind of list out our steps in the comments here. So obtain the xform if one is configured. Add a node in the hierarchy. And then process attachments. If I could spell attachments correctly. And then the last step is going to be process children, right? So processing the attachments. Let's see, we have scene node config, that's just a D array of attachments. Okay, so we'll say if node attachments, right? So if we have something to actually process, then we can say u32 attachment count equals D array length node attachments, and then for u32 I equals 0, I is less than attachment count plus I. And then we're going to need something to process the attachments. We could do this in line. Or we could like switch Yeah, I think I'm going to do it in line. So what I'm thinking here is we basically take a look at the attachment. So we'll say scene node attachment config. And we're going to call this attachment. And we're going to take the address of node attachments sub I. And then we're going to do the type of that. So we're going to say scene node attachment type attachment type equals, and then we are going to we're going to dereference attachment and then cast that to scene node attachment type. And that will give us what the attachment type is. And then we can do a switch based on the attachment type. And, just fill out the case statement. I'm actually just going to nab these real quick. Okay, so we'll do this case first. Oops. And we're also going to pair that with default. Let me just add these cases over here first. All right. Okay, and then there we go. Okay, so now that's basically how we're going to handle our attachment types, right? What is this bleating about? We should be able to... Oh, we can't dereference a void pointer, can we? Okay, well, that's not a huge deal. We can cast it to 2. Instead of doing that, we can cast it to this and then dereference that whole thing. All right, so we've got that. And then switch on that. Okay, so yeah, it just becomes a simple cast of the actual structure type, and that gives us the type, right? Nice and simple. And then we can basically go through each one of these. So obviously the unknown type is going to be an unknown attachment type was found in config. This attachment will be ignored. All right, so that's that one. And actually, instead of breaking here, I'm going to do continue. Because there's nothing else we can do with it. And then I guess we'll do this so that we remember to come back. All right, so we've got that. So we'll process those. I just kind of want to get the rest of this function worked out. And then the next thing we have to do is process the children nodes. So this is going to be just recursive, right? So we say if node children. We'll scroll this up so you guys can see it. So it's hopefully not behind my camera. So we'll say if node children, U32 child or children child count, I guess it'll be, equals darray length node children. And then for u32 equals 0, I is less than child counts plus I. And then we'll do scene node initialize, pass along the scene. The parent handle is now going to be ads. Because we have ads, Bezos has arrived, as Thor would say. So we just like to pause the stream whenever ads are here. At least on the Twitch side, we're served with those once every 30 minutes for 90 seconds. So, hydrate. All right. So we've just got about a little under a minute left. Hope everybody on the YouTube side is doing well, by the way. It's a little quieter over on that side tonight, but I hope you all are doing well. Tonight's kind of one of those nights where we're just kind of trying to get stuff done, you know? Some nights we have lots of banter back and forth, and other nights it's like, focus and get things done. It's the way it rolls, right? All right, so we're almost done with ads. And then we'll be back to it. All right, ads are dead. We are back. So just to recap, we like to break the stream whenever ads show up. At least on the Twitch side, those are given to us once every 30 minutes for 90 seconds. So I like to use that as a chance to hydrate. You guys should do the same. That's why we put a timer there on the screen so you guys know how long it's going to be. All right, cool. So we are processing children. So for each one of these, we recursively call scene node initialize, pass the scene. For the parent handle, it's going to be the node handle that we just created here, right? So that is going to become the parent. So node handle. And then the scene node config is actually just going to be the address of node children sub I. And there we go. That will process this all the way down. So it'll process our sort of header level information. It'll get our X form if we have one, get our node in the hierarchy, process our attachments, which we need to fill out, and then process children, right? So in our scene initialize, we need to now make some changes to this. What is this bleating about? Incompatible pointer types. Is config already a pointer? It is. Okay. All right. So we also had here where we're adding the config nodes at the base level. So these are process root nodes, right? So within the scene itself, we're iterating those. So we need to actually call scene node initialize. We're going to pass along the scene, which is called scene here. Probably shouldn't be because that's the same as its type. So for parent handle, we actually need an invalid handle, right? And so we actually need to go, let's do it here. So we'll say k handle. Invalid handle, and we'll do k handle invalid. And the purpose of that is basically saying we don't have a parent, right? So invalid handle, and then the scene config node is going to be the address of config nodes, right? Let's see. Oh, nodes sub I, rather. Right? So we process our root nodes, and this kicks off that whole thing, and then it just kind of cascades down, right? Let's make a note in here. An invalid handle means there is no parent, which is true for root nodes. Okay, so the next step is going to actually be to kind of set up these things depending on the configuration type. So we're going to try and do this in line via the attachments thing, and we'll see how it works. So let's cut this and go back up to here. And in Skybox, let's plop this in here. And what I want to do is I'm actually just going to create a scope around this just so that we don't actually hit any issues with that. All right. So scene config, skybox name, and cube map name. Those are not a thing anymore because they are an attachment. So we can actually get rid of. We can get rid of that and that. Skybox config. Let's see, process. You can get rid of that. Only set up a skybox if a name and a cube map name are populated, otherwise there isn't one. Okay, that is no longer true. So our skybox config, we're going to set up the cube map name, and this is going to be, we want to change this out with string duplicate, and this is going to be, do we need to duplicate? Yeah, we do. This is going to be, is it node? Or was it attachments? It was attachment. Attachment. Right? And actually, we need to do a cast here, right? Supe, thank you so much for the gifted tier 1 sub. I appreciate that a lot, buddy. Appreciate that a lot. Let me go ahead and give a shout out, by the way, to my good buddy Supe. He is actually trying to kick off his channel, and so I want to definitely help him grow that. So I'm going to give a shout out to his channel. He is, I don't know if he's actually started streaming on it yet. I haven't looked yet, but I know he was talking about starting it. So I'm going to give him a shout out. He's got a bunch of he's really good at coming up with like witty quips and stuff like that. It's very interesting to listen to him when he's gaming and stuff. So definitely check him out at some point if you haven't already. Let's see, over on the YouTube side. Philippe, would you mind repeating that in English? Unfortunately, I can't read Portuguese. I only know it's Portuguese. I'm assuming because there's Brazil in there, but I know there's a lot of Brazilians in here. But yeah, unfortunately, I can't read Portuguese. But yeah, Supe, that was super nice of you, so thanks for that. Appreciate that, bud. All right. So, what we will do, we'll take the, we need a casted version of this. So we need a scene node attachment skybox, and we're going to call this typed attachment, and we're going to say equals attachment, right? So we're just going to change the type on that. Have to cast that, I suppose. The attachment is, it is taking a pointer to that, okay. Oh, wait a minute. Why did I do it this way? I should be taking, this should be void. This should be Yeah, that's fine. Okay. So we should be taking this as a void pointer and then casting it to the actual type here. I must have confused that along the way somewhere. So we get our typed attachments. The cube map name is going to be from typed attachment. Cube map name. And then we have scene skybox. And we allocate a skybox here. So this is going to have to change somewhat because that's a little bit it's a little bit awkward in terms of how that works. I probably should have done something besides the skybox first, but that's fine. Am I from the United States? Yes, I am. Yep, I'm in the U.S. But there's a lot of people in here that are from Brazil. We have a pretty large Brazil audience in here, actually. Ironically, some of the I don't think Trash Can is here tonight, and I don't think Taman is here tonight. But yeah, those two guys are definitely usually in chat, and they're both in Brazil as well. Let's see. How do I want to? So we don't really have... Theoretically, we could have more than one skybox in a scene. And I know that sounds weird. But actually, if you think about it, it might not be. So we might have the ability to switch back and forth between different skyboxes, potentially. Within a scene. So theoretically, we could have more than one. So maybe just having like hard-coded to one here isn't the way that we want to do it, right? Really like the content, #1 fan. Awesome. I appreciate that, Philippe. Appreciate that a lot. Thank you for the support. So we don't really want to have to do this, right? I know we're doing things where we look at the scene skybox to see if it exists, right? And we were just kind of doing this as like another one of those permanent temporary hacks, right? We don't really want to do that though. We do kick off the skybox create here. But this allocation to me is a little bit weird. So I think what we might do instead, let's see, where's the scene? Singular pointer to a skybox. Let's change that up. Let's change that up. We'll do... Let's call this skyboxes. Right? And we'll do... array of skyboxes. Because technically we could have more than one. And I'm thinking with the scene, like this is the kind of stuff that we should probably also have handles to internally or for external access. And then we should query the scene for any data that we need out of it, I'm thinking. Maybe when we set up our render data structure, maybe that's what we do. So we're gonna have to think about that a little bit as well. And probably have to move a little bit of data around to make that actually stick and make sense. But for right now, we are initializing this. So let's see, where do we create these D arrays? Here. Okay, so let's do skyboxes equals darray create skybox. I should probably do the same thing for directional lights. You probably won't ever use more than one, but you might. So let's just make this consistent, right? So darray of directional lights. And we'll rename this. I am going to stick with dir lights, right? Because directional is kind of long to type repeatedly. All right, darray creates directional light. Okay. So now those are all lists of renderable objects. And we can come in here to initialize. And so what we can do is we can say skybox SB, get rid of this allocate and free and that. And we'll do a skybox create, and we'll just pass the address of SB to that, right? So we'll do this skybox create that, bleat about it if it fails. Otherwise, we'll do scene skyboxes push, darray push rather. Darray push skyboxes, and then SB. Okay. Was it S instead of scene? I forget. Yeah. Okay. Let's see. One question: do you see the advantage of programming early in the morning? If yes, why? That solely depends on your sleeping habits, I believe. Right? Like in my case, when I'm doing work, I find that I am more more effective at programming early in the morning. Generally because that's time where there's not like a lot of other people online. So I tend to start my work kind of early so that I'm online and working and programming before everybody else is online, and conversations happen and stuff like that. So from that perspective, I'm less distracted. But generally speaking, there's also sort of the mid-morning meetings that always tend to happen. And so I can't be as effective for that, when working. So I don't know. There's times in the morning where I'm effective, and then there's times in the early-ish afternoon where I'm effective. But yeah, I mean, like towards the end of the day, not as much. At night, I'm definitely a little bit better as well once I've had a step away from it for a few hours. But yeah, I mean, it really depends on your schedule and like what meetings and stuff you have, or what other distractions you have that aren't necessarily related to whatever it is you're doing, if that makes sense. I hope that helps. It's kind of specific to the person too, to be honest. Okay. So we've created the skybox, pushed it into the skybox array. So we have these attachments and config. Did we ever sort this out in the scene though? So if we have I don't think we sorted this out on the scene side. So actually let's do to do use a scene node attachment. Because I don't think we actually have those yet. So we have these scene attachments. We have a resource handle. How do we want to manage that, actually? So do we use a type here as well? And then we have a node handle and a resource handle. So we can look these up, but like, how do we know which one of these resource stacks to look in? I think we actually need... I think we need that type here as well. So we're going to do the same thing, actually. We'll do scene attachment type, scene node attachment type. I think that makes sense. And then we have like a flat list of attachments. And that becomes our link between the hierarchy node and the attachment type itself. And we only really need to know that while we're traversing the hierarchy, right? So like when we are going through to like set up the render data for these objects, we can actually just iterate these lists of things themselves just like we do now, and that's fine. Because when we take the attachments, we'll also have this node handle, which we can also get the transform from that. So I think from that perspective, we should be fine. Just trying to think if there's anything that I'm going to run into. The only thing I can't think of is, okay, so let's say let's break this down for a second. Let's say we're iterating the meshes. For each one of these meshes, we need to know its world transform. So to get the world transform, oh, you know what? Let me think about this for a second. So the mesh doesn't have a transform anymore. It also doesn't have a handle to the transform, which it also should not. So what we really need to do is on the mesh, maybe the mesh should store an attachment ID. No, because we could technically have the same mesh referenced on multiple attachments. Because I want the ability to be able to do that. For example, if you wanted to render 3 instances of a trash bin, for example, it would make sense to use the same mesh instance for that with 3 different transforms, right? So we don't want to hold transform information here. That's why we got away from that in the first place. So we need a way to say, okay, for this mesh that we're iterating on, which one of these attachments do we use so that we can get a node out of the hierarchy for it? We could technically, I guess as we're preparing the render data, we could traverse the hierarchy itself to do that. But that seems to override the purpose of having these in flat arrays, because then that sort of busts our cache. Or cache lines. Gonna have to think about that for a second. Apotham, good to see you. Your buddy and you had a very long discussion argument about rewriting the game engine. We're working in Zig. You got him to reconsider. Awesome. That's good. Yeah. Rewriting the whole thing would have been absolutely, like, not worth it, in my opinion, right? So I'm glad you were able to resolve that. That's awesome. Let's see. MBM, first time chat. First off, welcome. I appreciate that. So what is a D array? So a D array is a dynamic array. So the way that our dynamic arrays work is they're set up through... Here, I'll just actually open this up. So we have here is, let me see. So we have this macro, right, for darray create. And what it is it's a dynamic array that has header information within its block of memory that it allocates. That indicates how big each element is, what type of data is being stored, how many elements we have in there, and so forth, right? And so what it does is it allows us to easily create an array of a given type. From that type, we're able to extract the size through this, right? We can also reserve a certain number of those, like you might have in an std vector, for example, right? And then if you actually have a look in darray create, which is like the sort of internal, what this does is it creates a internal darray header. This darray header has our capacity, our length, and our stride, right? And also it can hold a frame allocator, which is just a special type of memory allocator that we can use. So ordinarily the way it works is you basically just say, okay, I want to create an array of this length. Each element is the stride size, and then potentially use an allocator. So it sets up the header size by doing the size of the array header, and it figures out the array size, which is the length times the stride, which is your normal array. And then if we are using this allocator, it uses that to allocate some memory. Otherwise, we allocate from our memory manager. We then we basically take the new header that we allocate, and we prepend the header size onto that. So we have the size of the array that we need, or the size of memory that we need for the array data, and then we prepend the header onto that. And that allows us to basically move a pointer around and say, okay, if we need to extract the header data, we move the pointer back. In this case, I think it was like 32 bytes. And then if we just want the array, we actually know where to look for that too. So it's a way for us to be able to embed header data in the array, but then also still be able to access it as if it were a normal C array. So it's kind of a way that we've done to make arrays convenient to use, if that makes sense. Let's see. Supe. Sorry, had to verify my phone and Twitch was being a bananas. Thanks for the shout out. Yeah, no problem. Yeah, I'm well aware of Twitch being a bananas and all of its bananery. Very familiar with that. You're going to start streaming next week. That's awesome. Okay. So yeah, definitely DM me your streaming schedule and I'll give you shout outs because I know you're trying to get that launched. So appreciate that. Yeah, I was ready to walk away from the project. So glad got it resolved. Yeah. I mean, I've walked away from projects where people are like, we need to do it in this language. And I'm like, but we already have it written and all this stuff like done over here. Sometimes it's not worth it, right? All right. So that is, I hope that answers the question about the D array, by the way. Let's see. Hello, not been able to catch one of these for a while. I want to make a game engine. I installed WSL on my PC so I can build Linux and have support for Windows. That may be tricky. The only troubling thing is looking for a build system. CMake is too complicated for me. I agree. Make is less complicated, but you don't entirely understand it. Well, that makes two of us. I don't know if anybody entirely understands Make. But the build system that I've come up with is relatively simple. I don't really like using a lot of those out-of-the-box build systems because I find them overly complicated for what they are. So yeah, usually what I do is I start off just kind of with like a simple shell script or a batch file, depending on what platform you're on, that calls Clang and does the thing for me. But eventually I wind up with something like this, right? And actually these two, I'm going to be combining them into one at some point because they're like 90% the same, right? But, you just set your your flags and stuff in here. Like, there are videos where I talk about like all of this stuff, but like once you get this sorted, you never really have to touch it again. Like, not very often, right? I would suggest at least kind of trying to make something using makefiles, because it will help you understand what all these other systems are kind of doing under the hood, right? CMake and all these things, they're essentially doing all of this stuff under the hood, more or less. So I would suggest at least have a fundamental understanding of makefiles, even if you don't understand all the ins and outs of it, and roll with that. You probably won't need it until you start having lots of dependencies, though, to be quite honest. So you may not need it right away. But that's more or less my recommendation, right? The only thing that you might run into issues with is on WSL, you might run into issues trying to run graphical applications if you don't have some sort of a windowing system hooked up. And I know that there are ways to do that, but they're hacky, at least the last time I tried it, right? So you may run into issues actually doing that. You might be better off setting up a virtual machine and or dual booting like I do. That might be the way to go for that, at least for graphics programming specifically, right? Let's see. I think I went on a 6-hour rant about CMake to your wife the other day. You haven't touched it since. Yeah. I think we've all had rants about CMake at one point or another. It's good for what it does, I guess, but if you need that complexity, but 90% of the time, I don't think you do. WSL2 has support for GUI apps, apparently. Does it? Okay, because I remember with I haven't admittedly used it in a while. I usually just boot to Linux if I need to do Linux stuff. But last time I did it, I had to like set up an X server for Windows, and it was a thing that existed, and it kind of worked. So it'll be interesting to see if not only that works with GUI apps, but also specifically GPU-driven GUI apps, right? That would be, if you get that working, let me know, because I would be interested in that for sure. Super interested. It uses an actual kernel rather than an emulation layer. That I did know. But how does it handle... Because like Windows doesn't have a display server, right? It doesn't have that. So how does it actually handle that is my question. Yeah, exactly. You'll have to look into it. Yeah. I remember I was able to hack it together at one point and get it working on WSL1, but I don't know how it would work on 2. Okay. Let's see. So... we need to think about scene attachments and how we sort of... How do we get our scene attachment index from here? Do we group these together maybe? So that we have like a structure with meshes and a list of its attachments, right, for quick lookup, and then one for terrains, one for skyboxes, etc. That'd be an easy way to do it, and probably a cache coherent way to do it. Cache friendly, rather. Actually, I'm thinking that might actually be the way to go. Because if we do that, then we could use the same index for both, right? So as we're looping through one, we can loop through the other. And actually, it wouldn't even have to be... it wouldn't even have to be a list of scene attachments. Come to think of it. It would actually just have to be a list of indices into the scene attachment. That's how we're going to do it. That's how we're going to do it. Okay, so let's do for the first one we're handling is skyboxes. I guess we'll try that one first. So we'll do U32 pointer. And this is going to be skybox attachment IDs. Or not IDs, indices. Right? And this is going to be indices into the attachment array for Xform lookups. So in other words, as we're looping through the skybox array, we're also looping through the skybox attachment indices. And we could say, okay, for this skybox, this is the index into the array which we haven't created. So we should probably do that too. What is this? Scene attachment. Attachments. So attachment data for the scene. Assists and lookups for Xforms and hierarchy. So for each attachment, this will essentially be a list of all attachments, right? We'll set each one up for each attachment throughout the entire scene. And then each attachment type will also have its attachment indices where it can look that up. And we'll have to come up with some logic to actually get attachment indices and stuff like that. It shouldn't be too big of a deal though. Okay, so I should probably put in here what I'm thinking because I don't want to lose track of it. So we'll say each resource, i.e. terrains, meshes, skyboxes, etc. Has a list of accompanying attachment indices, which look up into the attachments array. This array is then used to look up into the hierarchy graph, which then provides an Xform. So each type can be iterated along with attachment indices in a cache-friendly way. Okay. And I'm putting that left off there because I need to kind of get up early in the morning because I've got some stuff I need to handle. But I don't want to forget where I was. So I'm also going to do this. And I'm going to check this stuff in. So gets status. Those are the files we've changed tonight. Diff Okay. So we're going to call this... we're going to call this work in progress. Scene node attachments. Let's get that pushed up so that you guys can actually have access to that branch. I highly doubt this will build. In fact, I know it won't because there was errors in the code. But it's there if you guys want it. So that is pretty much where we're going to leave it for tonight. I do want to take a quick second and just see who is on for us to raid. But before I do, I want to thank all of you guys for joining me here, both on the Twitch side and the YouTube side. I really appreciate you guys being here. If you haven't already, I would encourage you to follow me in at least one, if not both places, just to follow along with the project. It helps me grow the channel. I'm trying to motivate and inspire people to want to develop game engines so that we have more competition out there, right? Because I think that's a very good thing. And I definitely want to see less of people being beholden to these massive corporations which have domination over these game engines that are out there, and then can pull a Unity and do some weird licensing crap, right? That nobody wants or likes. So the more people that are motivated to do this, the better, I think. So that's the cause anyways. So yeah, greatly appreciate it. Nanobots, appreciate the first time chat there. Welcome. All right, so yeah, if you guys haven't followed me already, I would greatly appreciate it. Like I said, it helps me grow the channel and spread the word as well. So that being said, let me have a quick look. I'm actually going to look on Twitch itself and see who all is streaming. Let's see. Give me just a moment to pick a stream here. All right. Let's go with something along the same lines of what I've done before, but a different channel. Somebody that I haven't raided before, actually. So we're gonna raid Alveus Sanctuary, which is an animal sanctuary that is a nonprofit. It's a really good cause. It's a rescue for many types of animals, and I think it's a super interesting channel. And they also do occasionally just stream on there and show the animals and stuff like that. Right now, I think it's just sort of different cameras showing some of the different animals that they have there at the sanctuary. But the ad revenue helps pay for that stuff, right? So I think it's a really good cause. And so tonight, that's what we're going to do. So let me just click that. All right. All right. So yeah, thank you guys so much for being here. I really appreciate it. And yeah, I will see you guys on the next one. See ya.